thank you everyone for joining us for our third virtual discussion on soybean gall midge. I'm Erin Hodson at Iowa State University, and I'm going to be your moderator for today. First off, we'd like to say thank you to those that have made this series possible, especially Phyllis Bongard at the University of Minnesota Extension. She developed the website, the registration that you use to access the discussion, and she's working behind the scenes right now to make us all look good. And along with Bruce Potter, made the CCA CEUs possible for this series. We also have a number of state, regional, and national soybean commodity boards, especially the North Central Soybean Research Program and the United Soybean Board. We've had a number of federal funding projects, including the North Central IPM Center, USDA NEPA, and USDA Crop Protection and Pest Management grants. And then, of course, we have a large number of industry sponsors, and you saw a lot of those as we kind of scrolled through, waiting for the webinar to start. And so we really appreciate all these sources for their interest in the pests and also helping support our research and extension for this emerging pest issue. We'd like to give a special thanks to farmers. Many of us have been working on farm, and they let us set up some sometimes crazy projects to try and learn more about the biology and life cycle of this new pest. So we really thank you for letting us work on your farms. And so with that, we have, as the title of the discussion series indicates, this is more informal. It's not going to be us talking at you for an hour. And today we're going to have 3 short presentations with time in between for questions. So in order for us to see your questions, you have to use the Q&A box. So it's a little button on the bottom panel of your Zoom. And if you click on that, hopefully a Q&A box pops up, and that's how we're going to read your questions. So you won't be able to verbally ask us questions with this webinar setup. So hopefully you can see the Q&A button. For those of you that need CCAs and CEUs, Phyllis is going to provide a Google form link in the chat box as we wrap up at the end of the hour. And that takes a little bit longer. If you have access to a QR code reader, she's going to also put up a QR code that will get you your credits a little bit faster. But if you have any questions, any snags with CCAs, that kind of thing, please get in contact in the chat box with Phyllis, and we'll make sure you get your credits. Just to let you know that our session today is being recorded, and it will be made available for on-demand viewing with closed captioning in a little bit. It takes a little bit to get that formatting done, but that's going to be posted on our website, soybeangallmidge.org. So you can go back there. It's also a place where we're going to put events, different research and extension things going on. So it's a nice thing to bookmark. And then also, if you want to sign up for the Alert Network for as significant events happen in 2021, you can get notifications for that. Okay, so our third discussion series today is all about management and implications for soybean gall midge. So we're going to get started, and our first presentation is with Dr. Justin McNicken from the University of Minnesota. So take it away, Justin.
Okay, yeah, so I'm going to start off this conversation focusing on the cultural, genetic, and then start to dig into the chemical management strategies that we've been looking at over the past 2 years. Now, if you join this presentation hoping that today you're going to learn about a silver bullet for soybean gall midge, you can just close your computer now and walk away. There are clearly no silver bullets that have emerged yet on this insect. I'm going to briefly touch on just a single slide on some of the biology that we're dealing with this particular insect. But you know, the goal is to give you an understanding of what we've seen so far, that things are not set in stone yet, and most importantly, what you hear today may not be the result that we see in 2021. It's been evident just over the last 2 years, and I'll show a couple of multi-year studies that we see a lot of variability year to year with this particular insect. So, of course, I'm Justin McNicken with the University of Nebraska-Lincoln, and I'm a crop protection and cropping systems specialist in East Central Nebraska. So to begin this conversation, the slide should look familiar if you've seen the previous presentations or the one where we were discussing biology and ecology. And I just want to reiterate for you the management challenges that we're facing. And number one is really the duration of adult emergence. And in particular, this slide here shows that how long they emerge from last year's soybean field. So in lots of places where we have this issue. Corn follows soybeans. So we have them emerging from last year's soybean field and moving over. And that duration, how long they emerge from this site, is one of the significant challenges we face. And the variability year to year, as I mentioned earlier, is pretty high. 15 days in 2019, which seemed long but practical. And then 2020 here, which you're going to see a lot of studies for management on today, increasing that by 10 days on average and up to 34 days, just provides a significant challenge for us, or presents a significant challenge. So again, the variation in pressure and injury between years has varied a lot, even between states within a given year. And then those environmental interactions that we don't fully understand as they interact with either the chemistries or different tactics that we apply. And then lastly, as a number of conversations and questions came in on the larval feeding location and what types of chemistries can be used in that particular scenario. So this is page one of a very long book that will eventually be the understanding of this insect over the next number of years. So I want to start with some cultural control strategies, in particular, looking at tillage. And this is a multi-slide set here, but first start by just indicating we've run two in East Central Nebraska and had big plans to follow up on this past year, and then with the limitations of COVID, we're unable to follow those studies. So we've done two spring tillages in my area, and then Tom in the Northeast has done some fall tillage studies, looking at some sandy soils there. Now I'll just briefly highlight Tom's in that there was pretty low adult emergence, so it was difficult to tell the impact, and he got some numerical differences. But again, these are fall or spring. You're going to see the spring emergence data here in a second. They both need a follow-up. What we're doing in a lot of cases on these studies, this was one of them, we just back up to the field edge. The grower did this and disked their way out of the field down to a depth of about 3 inches. And then we put cages on and off of these sites, these overwintering emergence cages, and monitored for adult emergence from those sites. What you see here is two sites conducted in 2019. You notice there's no statistics on it. This is just kind of observational. You'll notice a slight reduction with tillage, but you should also note is these early emerging in greater numbers with the tillage treatments, which regard kind of warming up the soils. So we have some numerical differences here, much like what Tom saw, a slight reduction with tillage. But we honestly can't tell you in either study if this reduction in number meant anything for the adjacent field in terms of reducing the amount of injury. Bruce Potter's on here, and I highly recommend this, that you use either the QR code here with your phone or follow this link through and fill out a survey for Minnesota that he started on tillage, looking at soybean gall midge, to help us out in better understanding what's going on with this. Switching gears a little bit and looking at mowing in terms of an opportunity. This has been 1 year, and I should mention that a number of growers came to me at the end of the season here with some information in terms of what they tried in 2020. But these are grass waterways between fields or along the edges of fields. This separates what in 2019 when we did this study, which was last year's soybean field, this year's corn that the adults were emerging from. A grass waterway between two fields, and then between each one of these flags, we had mowed the space between two different colored flags. So this whole space out here was mowed, but then we left this 20-foot area unmowed, and that's what you see in this image here, which shows the random pattern of that. In 2019, we were still sorting out, and we are still sorting out how to evaluate this insect in the field. And so this was, just the number of plants that were infested, and then some hand-collected yields at the end of the season. Initially, the infested plants from those sites, so on the x-axis here from the edge of the field where the grass would or would not be in the case of mowed or unmowed, and then distance out into the field. And we pulled 10 plants in 2 places from each one of these different locations, and then looked at the number of plants that had any soybean gall midge infestation in mid-July. And you can see we got some differences here right at the 10-foot mark, but then as we move out into the field, clearly there are no differences further out in the field. So I think there's more to be done with this. Some growers did this, thought they saw some results. It's nice to get the kind of more detailed information and that randomization to make sure that we're getting a good assessment of that. But this is a tactic that's kind of on our radar to continue to assess in the future. Yield differences on this, some slight differences here near the field edge, and actually greater distances or greater yield differences as we move out from the field border. And you can see that 6 and 3 bushel numerical difference, and so this is one I think that is worth looking at and continuing to look at, but certainly we need a lot more data on this one to feel more comfortable about it. I'm going to shift here to the genetic side of thing, which is this is a starter conversation. Dr. George Graff here at the University of Nebraska is helping lead an objective with the North Central Soybean Research Program. So we greatly appreciate their support on this. This is a big task for all of us. Looking at 768 lines that represent kind of the diversity for accession lines from the U.S. germplasm. There are obviously a lot more than that in the germplasm. And then we had 166 elite lines from the program here in Nebraska. We got this in at 3 different locations: East Central Nebraska, Northeast Nebraska, and Western Iowa. And you can just see the trial here. I mean, these have a lot of physical differences just in their growth characteristics, with the different lines that range from a maturity group 1 all the way through 4. But you could see here just in the later season photos, the lines are pretty close together in these photos, but this is actually one line right here. And then adjacent here is another line. So again, we're not saying there's definite sources of resistance out there or anything, but we were getting differentiation in terms of injury between those lines. And a couple more photos here between 2 lines. And so what were the results of this kind of first year was that we really took out a lot of the germplasm in terms of infestation. So if larvae were present, this essentially represents those lines of the 768 that were, which was we are at 98.8 in Iowa and 97.8% of those lines infested this past year, with just 12 lines in Iowa and 18 lines in Nebraska. I wouldn't say like, hey, they've got some resistant lines out there. These could have escaped infestation or be less desirable, perhaps. And we'll be continuing this coming year and probably the following year as part of the North Central Soybean Research Program, United Soybean Board. As we increase plot size, we may get different responses to those. This is just a photo showing one of those lines that we couldn't find any infestations in. So again, kind of a glimmer of hope there, but a long ways to go in terms of understanding this relationship. I'm going to shift now for the remainder of this to first another cultural control strategy, which is planting date, which you see a pretty complex kind of set of a graph here that's going to get more complex here in the next slide or two. So I'm going to leave this up for a second while I explain this. But we're going to look at planting date on its own, which we did in 2019. And then we're going to look at planting date with the addition of a seed treatment this past year in 2020. And I've got soybean development stage up here because that's critical to our previous conversation. So I won't hit all of it in detail, but if you want to learn more, go back and look over those other slides as they become available through our websites here. So we got a couple different planting dates here, starting from May 1, May 15, May 31, and June 15, all kind of stacked up here. I'm going to add the development stages for those soybeans as they emerge to the ground for each planting date. And then on the bottom here, I have soybean gall midge adult emergence, which is a number of adults emerging here on the y-axis, and on the x-axis is time. And luckily this year with this planting date study, we were able to document the other generations. And this is just one site for this particular, the network that occurs each year. So you got all these different development stages up here. It just gives you a rough idea of where soybeans were in terms of their development as adults were emerging in the field here, which started at this particular site on the 18th. And I want to highlight a couple things for you, focusing kind of solely on overwintering generation, which as a farmer or somebody managing fields adjacent to those that are infested, our key role in all of management, if we kind of highlight the overarching goal, is to limit overwintering infestations or that overwintering generation's ability to infest adjacent plants. And you'll remember from our previous conversation, we had a stage limitation where soybean gall midge didn't appear to have the necessary fissures available on soybean plants to infest prior to approximately the V2 stage or around the V2 stage in soybean. And so what we've done is we've marked V2 stages when they occurred for each one of those planting dates. And you can see they vary through the course of overwintering emergence. And that seems to relate to the likelihood of those plants being infested, with those that reach V2 prior to adult emergence being pretty well infested, up to 50%. That third planting date getting some infestation, but considerably lower. And this June 15th, actually escaping it, even though we had a little bit of emergence here, escaping infestation. So all plants were present. We couldn't find any larvae present on those plants when they were evaluated in July on the 12th. Move ahead to after first generation has emerged. Very different picture. Everything's now infested. We don't know if this would represent larger field scale scenarios. Small plots have their issues, and the fact that when adults emerge from those that did get infested, they could easily move to other plots. So this is, again, a starter to a conversation. Now, anybody, if you're grumbling in the background and I can't hear you, I can mentally hear all of you thinking, well, I don't really want to delay my planting of soybeans because if this wasn't a graph associated with soybean gall, which we know that delaying through May has some yield losses associated with it, 5/8 of a bushel on a good year, quarter of a bushel on a bad year per day, every day in May. But you'll notice here that our May 1st is actually less in yield than what it was on May 14th. And yields weren't terrible for the amount of pressure that was at the site, which is good. But all the way through June 15th, really didn't see any differences in yield. And so some of you took this advice in 2020. We appreciate your trust and confidence. You probably lost some of that based on what I'm about to show you about our 2020 data. But again, the challenges with this insect, 15 days of emergence on average this year, this 2019 year versus 2020. And so you notice I've got some highlights over this because this study is in its first year. And Natasha Umes, who's actually online joining us, she'll be coming up to Nebraska here in a couple months. She'll continue to work on this project. But I want to show you the complication now year to year. So let's do those similar planting dates. We went a little bit earlier, starting on April 22nd and going all the way through June 1st in this particular case. It's just two graphs, one with the number of larvae per plant, another one with the frequency of infested plants. And you notice the high levels of infestation of larvae per plant. The number of larvae on plant are higher in these earlier planting dates. And the decline, that matches what we saw in 2019. And similar here in terms of the number or proportion of infested plants, which is what you were looking at in the last graph. And so you can see, we got to larval number this year, but this is definitely similar. So we were anticipating somewhat of a similar response. And unfortunately, it really doesn't match because if this was to match the graphs as they're higher for the infestation and the number of larvae, we would expect to subsequently lower yield for those treatments. And instead, where highest yields are in the earliest planting dates for this particular year and really took a hit after the 12th, even though they were lower in initial infestation and injury. And these numbers for larval frequency and infestation were taken in late June, about 14 days after first adult emergence. And again, there's some temporal data that'll be needed on that, continually assessing these plants throughout the season that Natasha will pick up on when she's here. So it did not correspond with final yield in terms of the amount of larvae that were present. This is a continuing thing that we see, and I think it indicates a lot of the lack of differences are likely due to just continued adult emergence at these sites and pressure. If we were to kind of estimate what might be going on in this scenario, the yield differences we're seeing are likely a result of just the plant size and stage. So obviously earlier plantings were more developed when soybean gall midge first got to them, and perhaps that's what allowed them to continue to yield. So this is the start of a conversation on this. We have Nebraska soybean checkoff funding to continue this, into the next couple of years here to get a better understanding of this relationship. We may see a different response next year. I'm going to switch gears here. We've just kind of hit seed treatments. We've done a few other seed treatment studies, and we're seeing that rough, kind of 6 bushel yield response, not always significant in all cases. But now switching gears and moving into in-furrow treatments. looking at something that some of you are probably not familiar with being used in soybeans, but the use of Thimet. This was the first year of this study. It's a group 1, of course, organophosphate or phorate. You can see the rates that were used in that study, and you can see these, again, this is late June, similar time evaluation. All of them relate to whatever number here is on the y-axis. We have the frequency of infested plants and the average number of larvae per plant, and then the subsequent yield at the end of the season. And this certainly looks appealing to see this. You know, our yields got up to about 55 bushels, so there's this stretch up to where yield potential was in that field. And there's some confounding variables with the edge of the field. But what you see is as we increase rate, we got an increased yield, as well as kind of an immediate drop in the average number of larvae per plant. Not really any differences, wide variations in the frequency of infested plants. Another way to look at this is just the injury over time on these plants, which this was data that was collected and added to Mitchell Helton, who's also on here, a master's student in Iowa with Aaron Hodgsons and I. You know, and he's looking at this for modeling. This just gives you an idea of relative to that check, you know, the greater the injury score, the more the injury that was present, how that check kind of rapidly climbed up, and the others also continued to increase just at a less of an intensive rate as we move from July to August. I want to give you 2 sites here. So this is a site with a little less pressure, same number of treatments. I should mention the previous one was planted on May 12th. This one was planted on May 3rd. I can't say anything about planting date, but it's an important question we need to ask ourselves. You know, much like the gaucho that was used as a seed treatment and how that might relate to control. But you can see we got some differences here with the highest rate, but the yields overall were pretty good. And of course, you know, early in the season here, we saw that drop in terms of number of larvae with higher rate. And the frequency of infested plants with a higher rate. So this is the start of this one. Don't hang your hat on it. I think we need to do some more work. It's hopeful, but there's obviously some room to grow. And then this is the injury scores, far less if you compare it to the previous graph in terms of total injury, but a steady climb here towards the end of the season. So, you know, on Thimet, you know, just this gives you a visual at what was the first study site. The black are the checks, so there's some obvious visual differences over the tops of the plots. You could still see injury even when we were using a high rate. This is how we did it, was a granular T-band applied at planting. You have to read the label on this. It must be incorporated into the soil, and there are some restrictions on that. You know, $40 to $50 an acre. So this isn't a cheap application to make. The yield differences were pretty significant, but again, that, you know, you want to be careful and make sure that you have pressure and you know, can follow the label on this. We have 1 year of data. I want to really stress that, you know, interactions with environment and planting data are unknown. And then another thing to watch is herbicide interactions. Avoid, for now at least, we may be doing some studies this coming year, avoid the group 2 herbicides 5 and 27. 5 is the one documented for soybean, but 2 and 27 are on corn. So that's just one to watch for. And then with anything we discussed today, always read the label on these, you know, before you use them or decide to get them as part of your tactics. You know, some treatment considerations. Aaron's going to hit up on the second bullet point. I'm just going to mention it here now. No interventions needed unless there's notable yield loss from soybean gall midge, unless notable yield loss from soybean gall midge occurred the previous year. You know, mowing and early treatments have some other issues, and Aaron will explain that in more detail. So we have to be careful about how we approach this. And then, you know, lastly, kind of cultural control strategies have some potential. I think, you know, there's some numerical differences and things that need to be explored, but we really need more data on that. You know, the duration of adult emergence is going to impact these strategies each year. And then the lack of interactions, understanding of interactions between tactics, the environment, and just soybean gall midge itself is going to make this challenging. So that's what I had for our initial start, you know, kind of going from cultural to genetic to the initial studies on some chemical products that we'll continue on. But I'd be happy to take any questions, Aaron, if there are some.
Yeah, there's a few questions that came in. Thanks, Justin. You talked about soybean gall midge, the adults are not strong flyers. Did you look at prevailing winds with your mowing studies?
We did not, and that's, well, first of all, that's a great question, and I think these are things that we need to look at here eventually. Prevailing winds is a big question, just from the ecology, not even from a management standpoint. I think helps with management, obviously, but yeah, that's one that's been asked. It's one thing that cautions me on that is our cages really good at indicating the total period of activity from these sites. Aaron, you and others could certainly comment. I have several sites like that where we may catch very few adults, but then see injury, significant amounts of injury. And so, yes, we haven't, at least I haven't, others can comment. I think that's something we need to dig into.
Yeah.
Other comments on that?
Wondering if, in your mowing study, how many times did you mow?
Just once, right prior to adult emergence, was a grower that did the mowing with a flail mower. And so we didn't do multiple mowing events. I don't know if that would be necessary once they're in the soybean field. I don't, again, we don't know these things, but if I was to draw the important part, like we mentioned in the conversation, the overwintering generation is the key target.
I think our initial thoughts on the mowing for our initial studies were, and look at this, is we want to disrupt that overwintering population, that are the adults that are first coming out. So we wanted to diffuse that population, hopefully with, not providing them with a place to imbibe water, or for whatever reason they seem to like dense vegetation. So there are other permutations on this that we can explore later, but initially that was kind of, we're focusing on those adults that are coming out in the spring early. And so that's what that was initially directed at.
Justin, do you happen to know if there was overlap for the germplasm screen between Iowa and Nebraska? Were any of the genetics the same?
Yes, there was some overlap. I don't think it was consistent overlap, obviously, because 18 and 12, but we had some that were eliminated at one site because of another. That's a rather, I'm glad they asked, because that's a rather complicated thing, because we also have injury scores in Nebraska. And so the odds of finding something totally resistant are a little bit slimmer than finding something maybe tolerant that could take some injury. And so George is doing a GWAS analysis, which is genetic analysis, to figure out what we should put in next year. And so, again, a start to a conversation. At least it wasn't 100%.
For your tillage study, did you do the tillage in cornfields or soybean fields, or both?
Yeah, that image wasn't up very long, right, to get a chance to see that. So it was done on soybean stubble, which would have been, so the fields that you saw injury in this past year, those soybean stubble that are going to corn were, dissed or tilled in the spring. And Tom, likewise, the same thing, right, Tom?
Yeah, it was in the fall, and it was where we expected the larvae to be overwintering, which was that current year. For the fall tillage, it was that current year soybeans that fall. And in that one that we did in the fall tillage, it was pretty sandy soil, and it was shallow, very shallow tillage. So again, we took this is our first look at that between fall or even spring. And so there's different permutations on that. So we're going to look at that. We're going to continue to look at that in Nebraska and Minnesota and some other places. Yeah.
Okay. There's a lot of questions pouring in, and I want to make sure that we at least get to our second and third updates. So maybe, don't worry, we still have your questions. They're not going away, but maybe we will just transition to the second part, because I think some of the updates will provide answers to some of the questions that you guys have. So actually, I'm up next. And so I just want to make sure I'm sharing my slides correctly. There we go. Okay, so I have some efficacy evaluation updates as well. So hopefully that can answer some of your questions. And I wanted to acknowledge Mitchell Helton, who's a graduate student in my lab, co-advised by Justin, who helped me collect a lot of this data. So we'll get started here. I just want to provide a bit of a background for me. And that I've done some efficacy evaluations at Iowa State for 11 years on multiple pests, multiple locations, and my style, for lack of a better word, is to use replicated small plots in which I've looked at seed treatments in furrow, but in general foliar applications. And usually what we do is we sample the target pests or pests weekly from planting through harvest. So it's fairly intense level of data collection. And then we compare the treatments at the end of the year with yield responses. And so sometimes I'm asked to look at proprietary ingredients that are maybe new in the pipeline, but the vast majority are labeled or near labeled products. And so I compare X to Y, usually for products that people can get access to. And I happen to summarize all these data that I'm allowed to share publicly in what we call yellow books. And that's just an Iowa State thing for efficacy evaluation. So I have yellow books for soybean gall midge for 19 and 20. So if you happen to be a person that's like, I want to know the nozzles, the volume, the plot length, the seed genetics, this is for you. It has a lot of detail, which I won't go into, but they're available free. And I can put the link for the PDF in the chat box when I'm done. But even if you just Google Iowa State Yellow Book, this will come up for you. So in 19 and 20, I had 2 locations for soybean gall midge, one in Northwest Iowa near Sutherland, and then one in Southwest Iowa near Griswold. And in 19, I would consider an average planting date. And I had a bit more treatments than this, but these are the ones I'm able to share. And if you watched our second discussion, I talked a bit about the injury score. So we're not looking at larvae per plant because it's too time consuming and it's a destructive sample. So we were just looking at percent injured plants. And we're still kind of tweaking that system, but in 19, it was a 0 to 5. So 0 is a healthy plant, a 5 is a dead brown stick. And so you see we have a number of insecticidal seed treatments. So someone asked about gaucho as an in-furrow. I haven't done that, but I've used it as a seed treatment. And we had a spray on the 26th of June and a spray on the 11th of July. So we had a couple different timings based on adult activity. And you can see we had a lot of pressure at Griswold in 2019, in which most of the plots had injured plants and a lot of dead plants. And so with dead plants comes really severe yield losses. And so I asked, this was an on-farm project, and I asked the farmer what the average yield was before midges rolled in, and he said about 70 bushels per acre. So you can see some very dramatic yield losses associated with that. And just in general, the seed treatments did a little bit better. They were also a different seed genetics, so that sort of complicated the issue a little bit. But in general, when we're using a foliar, either a kind of a early or mid-season treatment, didn't really seem to have a good impact on yield protection. Last summer in 2020, we had the same 2 locations, but I would consider early planting date. This was the 3rd week of April. We were able to get plots in. And I also had a number of different treatments. These are the ones I can show you, but we had some seed treatments again. We had a little bit earlier spray, trying to be a little bit more proactive and based on growth stage, and also on 25th of June, so a little bit later spray. And the scale's a little bit different, but you can see overall the pressure of midges was dramatically less than in 2019. So even though this field was located about a half a mile away from the 2019, we had a lot less pressure, and which no matter what treatment, what timing, anything else that we did, you saw there's no difference in the injury scores at the end of the season. And without a lot of pressure, no matter what you're using for an insecticide, I wouldn't expect a big yield response. And so that's something I see for almost all those pests in soybeans. If you don't have enough pressure, you're not going to see the benefit of that spray. So that very bottom bar that says untreated control is bare naked seed. It was no different than some of the more very expensive treatments that we were putting on, some of the high insecticidal rates. And so I wouldn't associate the yield losses anything to do with midges, although this location was very drought stressed. So he didn't have a record-breaking, bin burster, but I wouldn't associate that with midges. It was more of those environmental conditions. So I get a lot of questions about people who are experiencing midges or maybe on the fringe, and they ask a lot of questions that Justin just talked about, some of the cultural control things like planting date, row spacing, and things like that. And I just want to caution people before you change up the whole program for the farm and start planting all the beans in June. Of course, most of you realize that as you push that planting date back, the yield potential goes dramatically down. So I just pulled some data from, we have northern Iowa and southern Iowa. As you push back the planting date, the yield potential goes down. So we don't even know if planting date helps or hurts midges at this point. So I wouldn't drastically change it. I would still plan on planting beans when you think is best as far as quick germination and vigorous growth. And that is a little bit dependent on the season, of course. Many people are interested in mowing and burning grassy edges or starting this really aggressive tillage program in fields that were infested last year. And Justin showed maybe some, data that it's not consistent. Sometimes it seems to influence the midges, and other times it doesn't have a response. And so our recommendation at this time is not to drastically change this mechanical control, to smack down those midges. We just don't know if it has a beneficial effect. And so the cost and the time involved, we just don't know if it really pays off. But that, to let you know, that research is ongoing. And then there's some farmers who are, they've been experiencing these really dramatic yield losses, especially on field edges, for a couple of years. They've tried the cultural, they've tried the mechanical, and then they've also dabbled in their own chemical control program without a lot of success. And so what their option, what they feel like is, I'm just going to opt out of soybean and I'm going to plant corn because midges don't feed on corn, which seems like a viable option, but you may be promoting some other issues like with corn rootworm or pathogens in corn or other issues that, as far as agronomically could be helpful or hurt your program. And so we're not suggesting that you opt out of soybean, especially with all of the commodity support that we get. We wouldn't want to say that, but it's that has become the level at which a farmer gets super frustrated, and that's what they feel like is an option for them. What most people go to is their first response, as with almost any soybean pest, is I want to use insecticides. When, how often, what type of application, that kind of thing. Early and often is a strategy that some people are putting on their own personal farms. And so, as you can see, many of us are looking at a wide range of insecticidal group numbers or active ingredients. We're looking at different sites and also timing, or maybe multiple timings. And this is just newly emerging research, basically 2 years of research with kind of highly variable midge responses. We have not gotten to the point at which we can have a recommendation based on spray this and expect this type of yield response or this return on investment. So we're sort of, I'm personally hesitant to recommend a program if I don't think the odds of breaking even are good. And certainly we're not getting a positive return on investment. So the reason we're hesitant is because it's very expensive, but also some of the environmental costs to the early and often insecticide approach. And that's just because, Justin earlier mentioned how mowing, burning, and tillage can impact the surrounding environment. And sometimes when you take away that grassy refuge, it pushes things like spider mites and others that use it as a refuge into the field sooner than it normally would, especially if you have drought conditions. So we're worried about flaring up pests that we don't normally have to think about, like spider mites and some of the other ones that use those grassy borders. And then I just think about all the seed and seedling pests in soybean and whether or not the insecticide exposure can actually make them more intense, or you have those secondary flares that come up. And then I also think that about all the exposure of the insecticides to pollinators, and also much of the area that has soybean gall midge also has populations of resistant soybean aphid to certain pyrethroids. And so we're worried about actually flaring up soybean aphids later in the season. So there's just some pros and cons to using that. And so we're hesitant to have a program for you if we don't think it makes economic or environmental sense right now. So I just had those few slides on. I can take a few questions if you had them, or Justin also has a program in Bruce too. So let's see, I will stop sharing and see what kind of questions came in. Lots of questions. I'm going to defer all of the biological and predators things for now, just because we spent quite a bit of time talking about it in our second session, if that's okay with the group. Justin, or anybody else, did you look at in-furrow gaucho or just as a seed treatment?
Just as a seed treatment, Scott asked one that I think I want to catch really quick, which
Yeah.
you talk about ringing the field with thiamine. That's an important one, Scott, that we missed. I don't think in any case with any one of the products we're discussing or recommending, treating a whole field or anything like that. You want to stick to the field edge. That's an important part if you're considering treating. We don't have the exact answer on how far into a field, but the first 60 to 100 feet is where we see a lot of at least significant economic losses that are visually apparent. So, with these products, if you decide to go down that route, and Aaron, I think, pitched it very well, we are very much in a trying to understand phase rather than a providing recommendations phase. But we certainly don't want anybody with the cost of some of these, going out and treating large areas, so stick to field borders.
Yeah. Ronald asked about chlorpyrifos as a foliar and asked if we use it at all. We personally did not in Iowa. I don't know if other states use either as a single product or as like a cobalt mixed in with the pyrethroid. Did you, Justin?
Yeah, Tom can comment too. I've run cobalt, which has got chlorpyrifos in it. It's like a lot of other, I didn't test it in 2020. Tom could comment on that. We see that difference. It's not, not a huge difference where it stands out above a lot of the other things that we've tested, but has been tested.
Yeah, I saw in 2019, I had cobalt, and that was our best with respect to, number of injured plants, number of larvae per plant. But when it came to yield, there was no significant difference. That was one, spring application that we did, but that did stand out, and that was a cocktail. The chlorpyrifos by itself is probably a short residual. Remember, these things, even on our best year, they were flying for quite a while. So if some of the strategy when we were looking at things was to think, well, we probably want something with as long a residual as we can get, so that lent towards products that we thought might have a better effect would be ones that had a long residual. So we did see cobalt work out pretty good, but that was a cocktail with chlorpyrifos in it. I had Asana, and I think we've had, several other like pyrethroid types that initially looked good, but like I said, we didn't see any when it came to yield. There wasn't a significant difference along that edge, and it was a pretty big hit. So that's where we're at right now.
Mm-hmm.
But cobalt did pop out in our trial.
Has anyone looked at population density or row spacing? We have not at Iowa.
We not in a heavy amount of detail because we plugged those studies in 2020 and we're unable to follow them through in a lot of detail. I can tell you that going up to 320,000 plants per acre, which is a skyrocket above norm, is still infested. So that stem diameter, they still, at least for that particular variety, they still crack and form those fissures. We also looked at row spacing, but didn't pull any yields on any one of those studies. So it was more or less, are they still present in those treatments?
Yeah, and we found them present in all. When I was scouting, I'd see them in both. So I did no analysis of that. Just when I was doing my survey, I was stopping in whatever field I just pick a field, and I had narrow row drilled and 30-inch row, and if it was an area with soybean gall midge, I found them in all. It would be interesting to see if there are some slight, if there's some, maybe they go they don't go as far in initially or something like that, but we don't have answers to any of that yet. Those are, more studies to do.
Do you think that the use of thiamate influenced other seed and seedling pests in soybean?
Yeah, it's a good question. We scouted those fields and watched for any significant pest pressure that was outside of soybean gall midge and did not see it at either one of the two sites that I showed for data. There's the odd defoliator that's always present, but nothing that was in checks or otherwise to indicate significant pressure from another pest species.
We did not, and we also had questions about thistle caterpillar in 2019, if you can remember, like the invasion of thistle caterpillars, but didn't really seem to have an impact with our foliar program or seed treatments.
Yeah, I would imagine, you know, in our area, the ones that come in early are the bean leaf beetle, and sometimes we get some thistle caterpillar early. So I imagine it would affect bean leaf beetle early, and I imagine it might affect some of those very early caterpillars. But, you know, we get so many of our insects and really insect pressure like defoliators and pod feeders so late in the season that, you know, an early spring, whether it's a seed treatment or whatever, if there would be some kind of effect, I imagine it wouldn't be a management level effect. Just we might see, you know, something. So I wouldn't really expect much effect on other insects with these early spring applied products.
We have a couple of questions that I think might be best answered after our third update. So I'm thinking maybe we could move on to Vilma, and then hopefully some of those questions could get answered. But if not, we can continue the conversation after her updates. So go ahead, Vilma.
Hi everyone, my name is Vilma Montenegro and I am a master's student at University of Nebraska-Lincoln. Today I'm going to briefly present the results of one of my studies that is related to insecticide timing. So this study was basically conducted with the objective of evaluating 3 different types of insecticides. So we had an organophosphate, a pyrethroid, and also a neonicotinoid insecticide. And we were applying them at different times relative to overwintering soybean gall midge emergence. And as you remember, when we are talking about the overwintering generation, is that very first adult detection that we have. So the very first detection of the year. This study was conducted somewhere here in eastern Nebraska, near Memphis. And this is the table of treatments that we were using. So we had a control that is basically a plot that was never applied. Then we had an organophosphate for that we were using dimethoate LB4. We also had the pyrethroid hero and the neonicotinoid belay. And right here we have the doses we were using, and the timings for each one of these treatments were day 0, which means application the same day as emergence, the same days as we detected emergence in that specific field. Then 5 days after overwintering emergence and 10 days after overwintering emergence. And this experiment was conducted in a scenario like this. So basically we have our plots right here in a current year soybean, and then right across the street, we are gonna have a last year soybean that this year is gonna be planted, that in that year was planted with corn. So we will be collecting that overwintering generation from here. And we randomized all of the treatments. We had a total of 4 replications at the edge of the field, and each of those replications included all of the treatments. The major components we were evaluating for this study was infestation with soybean gall midge, also the number of larvae that we could find in a plant. We were using injury score, that is a system that is being developed by Iowa State University, and we were getting the yields. We were getting the yields by the end of the season. This is the timeline of the experiment. So basically, it started right here in June 13, when we had the first adult detection from the cages that we had to track emergence. And I have this plant right here because, as you remember, overwintering emergence is being collected from a field that is planted with corn in that current year, because that's the previous year's soybean. So that same day we sprayed the first timing, then 5 days later we had the second timing spray, and then 10 days later the third timing spray. The major components that I just mentioned in the slide before were evaluated twice during the season, once in June 30th, and then later in the season in July 23rd. At exception of the injury score evaluation, that this system was basically being evaluated every week during the entire season until we were pretty close to harvest. And as I mentioned, we are basically relying on that very first adult detection to start the applications. So we were using those cages that we have to track adult emergence in the field. And those cages were outside from May through September, and they were checked on a daily basis. The entire overwintering generation first and part of the second generation. Then we reduced the frequency that we were checking. But if you want more information on how this system works, you can always go back to the first 2 sessions where we provided more information about it. So we're using the information that we were collecting from 13 locations that we had in eastern Nebraska, plus some cages that were placed in some of the plots in my experiment. So right there in that same location. For the infestation, we were evaluating the number of infested plants. So that's basically a plot. And then from there, we will be taking the plants and evaluating whether they were infested with soybean gall midge or not. And as you can see here, this is how a healthy stem looks like, while this one is infested. So we can see here those dark spots at the base of the stem, and also find larvae when we open the stems. And in addition, we were also looking at the number of larvae, again, taking plants from there, taking a series of plants, bring them to the lab, and dissecting those plants and counting the number of larvae. Right here, we can see how we separate them. So this is how an egg look like, and then each one of the instars of larvae. And also we were doing this injury rating system that, as I mentioned, is developed by Iowa State University. It's specifically one of the projects of a master's student in Iowa, Mitchell Helton, and Dr. Erin Hudson. So if you want more information, you can always go back to the 2 previous sessions. But what we were doing here was using a scale from 0 to 4, and each number means a different percentage of plants injured. So we would be walking through the plots and assigning a number based on what we will see that it was the injury in that specific field. Now I'm quickly gonna go through the results for this experiment, and I just want you to consider that this is only 1 year of data. So what I am presenting is what we found last year, and it can always change, and we shouldn't be drawing conclusions just yet. This first graph shows the infestation. In the y-axis, we have the average percentage of infestation, and then right here we have all of the treatments. As I mentioned at the beginning, we had 2 evaluations. So we have in yellow the first evaluation that was early in the season, and we see how all of the treatments, including the check, were below 50% of infestation. While by the second evaluation that was later in the season, basically all of those treatments were highly infested with percentages up to 90%, and there were no significant differences between them. And we can actually see patterns in, at least for belay, the neonicotinoid. We see that the later we applied, we will be actually making it increase the average percentage of infestation in the field. However, for the others, we cannot clearly see patterns. And again, there are not significant differences here. We can basically see the same for the number of larvae per treatment. This graph is including the 3 instars of larvae right here. And then in the y-axis, we have the average number of larvae per plant, and then we have all of the treatments in the x-axis. As we did for the infestation, we had 2 times of evaluation. So in the first evaluation, we see that we have small numbers of larvae per plant, but then again, they are establishing in the field, and at some point by the second evaluation, all of those treatments were highly infested with larvae, and no significant differences were found between them. And for the average injury score per treatment, I said we were doing this weekly, but I picked 3 different dates to show you what was, to give you an idea of what was happening. So we have in yellow the 30th of June, that's 10 days after all of the plots were applied with its respective treatments. Then we have the orange that represents the 23rd of July, that is later in the season, 2-3 weeks after everything was applied. And then pretty late in the season, the 24th of August, when we were pretty close to harvest. And again, we see at the beginning, we have pretty low infestation, But then by the end of the season, there were no differences at all. All of the treatments were looking pretty much the same. And then what you guys might be wondering, let's look at the yields. We have right here in the y-axis the yield in bushels per acre, and then in the x-axis the treatments. And there were not any significant differences between treatments. So basically, everything was yielding around the 25s and 30s. And I actually have this in a scale of 60s because this specific field has a historical yield of 55 bushels per acre. And even though we tried these 3 different timings with 3 different products, we were not able to detect any differences in yield. And now I'm going to hand it over to Justin, and he's going to share a few slides with you.
Sure. Thanks, Vilma, and a good coverage of, you notice we're kind of expanding from the single application to what Vilma's is a single application at different times during adult emergence to say, is there a sweet spot to be found in there, which her 2019 data showed some opportunity, I think, but under a lower duration of emergence, and clearly with 2020 just kind of overwhelmed the system. So this is, the question about what happens if we go to 3 applications on the same plot. And there are different kind of orders of those applications that you can see here. Just to break apart the legend, first we have an untreated check with no application, no seed treatment of any kind. And then we have, either starting with Indigo ZC and going to Warrior and then Besiege, or different combinations of those, with all of them occurring even prior to adult emergence. So at V2 stage, just prior to adult emergence, which occurred 5 days later. And then 5 days after adult emergence, we made another application with whatever product was below that. And then 20 days after first adult emergence, or 2 weeks after that application, a third application. So this is, in the, to reiterate Aaron's concerns over a lot of early season applications, this is one where we essentially tried that, and you could see some yield differences there. We didn't get any differences in frequency of infested plants, some numerical reductions in the number of larvae per plants. This is again another one-time assessment. I think it would be nice to do multiple assessments, kind of like Vilma's study here in the future, to get a better handle on what's happening over time in these studies. It's just very labor intensive, and some details there on the types of nozzles and things that were used and the rates. And you can also see the group herbicides that were there, which are 3s, 4s, and a 28. This slide is much like the slides on that I was discussing earlier in my talk, which is just over time, that injury score relationship. So we're looking at the same treatments, same study. We're just looking now on the y-axis at the plant injury score, taken in July when injuries really start to show up. Nothing on the 25th of June when we did our evaluations for the larval numbers, but you can see that quick escalation in injury, which is something we've seen for the last couple years on heavily infested sites. And that rapidly escalates. And then for all those treatments, they're just slowly catching that. And so, 2020 was a pretty hard year for Eastern Nebraska. But this shows you that there's a lot of pressure out there in the particular case. Thanks, Vilma.
Okay, and then just as a summary, I just want you to go back to the fact that it's been difficult to develop efficient management strategies for soybean gall midge, considering that first we have a very long duration of the adult overwintering emergence period. Also, that we are lacking knowledge in the biology and ecology, since this is a new pest, but that's something that we are working on. And from this study, you can see that the no insecticide timing provides complete control of soybean gall midge, and there is not a significant difference on yield between the untreated plots versus the plots that were treated with the insecticides and the timings that were evaluated from these studies. And the results may vary based on pest pressure, the location, and duration of emergence. So that's something that we should be considering as well. So thanks for your attention. And we'll be happy to take questions if you have any.
Thanks, Vilma and Justin. We had a couple different questions that revolved around directing insecticidal sprays. at the base of soybean, maybe using pyrethroids or organophosphates. Do you have any more to add to that, Justin? Or maybe Bruce?
No, I'll go first, I guess, and Bruce can follow. Nothing to add yet, but we did purchase drop nozzles for our sprayer, and that's one that's high on our list for the coming year. Is, obviously these insects, the larvae are right at the base of the plant. And so you could think a lot of what we're doing right now is trying to perhaps kill adults that are coming into the system. But what happens if we target with those foliars towards the base of the plant? How would that change that equation? So I know there's probably some people cringing on the other end, thinking about drop nozzles and throwing those onto a sprayer. But again, exploring that as a possibility is important.
Justin, why did you use a T-band for Thimet instead of in-furrow?
Yeah, again, refer to the label. You can do other application methods. All must be incorporated. But that was to meet label requirements, and it's not that it's not in with the seed. It's very close to the seed. In fact, the furrow is still open when that T-band goes over, and it's right prior to row closure. And so when we set up that study with AMVAC, they wanted to not drop it in, also because I think it can harm the seed if it comes in contact, or a lot of it comes in contact with the seed. Good question.
Yeah, do we have any data to support that plants that are injured by soybean gall midge are more susceptible to fungal pathogens?
Oh, we have a study going right now. It's super fun. In fact, we're still not done data collection from 2021. I sat in my garage this weekend with some stems sampled from what was a fungicide kind of craze study versus no fungicide, and then fungicide, insecticide. And we're counting numbers from that. And then we have plant pathologists trying to understand, well, what was present right prior to adults showing up in that system after larvae initially show up. It's inconclusive at the moment. I won't give you a good answer, except for the fact that it's kind of like our general answer. We're tackling it. Year 2 will be critical to understanding that. It's an excellent question because related species show interactions with plant diseases. So I guess all I can say is we're on it. We don't have an answer yet.
Has anybody done any work with moldboard plowing? I thought maybe Bruce had. No? Okay.
We have not.
Okay.
Reasonable question, though.
Yeah.
No.
Go ahead, Bruce.
No, we haven't. The sites I'm working with that are the most heavily infested are strip tills. So that kind of limits our options on what we can do there. My question on the tillage is it may not be a field specific event. It might be an area event. And in other words, if you've got a lot of tillage in an area, that may suppress overall populations, that sort of thing. So that's what the survey is hopefully going to help us answer.
Okay. Yeah. Thanks, Bruce. Good reminder. We're in overtime now. So I just want to make sure that for those folks that need CCAs, you can see the QR code on the screen, but you can also use that Google form that Phyllis put in the chat box at the beginning. Any snags with getting those credits, please get in contact with Phyllis. We also have a survey for not only this session, but basically the discussion series. And we're really looking for some feedback if you like this format of sort of short updates with chances for questions and discussion. So Phyllis also put a link in the chat box. If you'd please fill it out, we'd really appreciate it. And we can justify our existence to our bosses. So thanks for that. And we can continue to answer a few more questions for you. Can anybody address how cover crops might help or hurt midges, either in the overwintering source or maybe the currently growing, like planting into green cover crops?
Here's another non-answer from me. We put in plots this year to look at this. So we have a cover crop, no cover crop comparison. We've seen, and if Gabby Carmona, my PhD student, was on here, she would tell you that we see increased predator activity in some of our studies, which could or could not. I mean, we don't know that answer is how well they're interacting with soybean gall midge as it's emerging, or the larvae. But we have that both in last year's soybean field, and then directly adjacent, we have that and stuff going into soybean. So kind of, good question. Hit pause. We'll talk again at the end of 2021, and I'll tell you we don't have enough data to understand it then, and we'll be looking at 2022. It takes a while to answer these things, unfortunately. We're not doing this out of humor or anything. It really is just challenging to draw an understanding in a year or two.
I'm wondering if anybody has done research on using fungicides. I assume as either as a seed treatment or early vegetative application to keep the plants healthier. Like I assume the question was plant bigger. Anybody looking at that?
Just that study we have in now, which has several foliar applications of fungicides. It's not anything a grower would ever want to do economically. And that's, we saw infestations in greenhouse in the absence of any disease presence. So that's an important thing to kind of plunk in the back of your mind.
And I will say, as far as, the seed treatment type of fungicides that people use, what they're using now, we would find if there's an area with soybean gall midge, it didn't matter whether there was seed treatment or not of fungicide.
Yeah, I would agree with you.
Those were the current things that people normally use. So I wouldn't say we didn't target it specifically and get information on it, but when they were in an area, they were on pretty much all beans.
Yeah, I would agree with you. Just my observations on commercial fields that had fungicidal seed treatments, it didn't seem to matter.
Yeah, correct. Same here. So that still remains a question, though, of what's going on. And Gary Yoon with UNL is on a project looking at the interactions with the seed corn maggot and disease. So hopefully we'll get something there. As we said at the very beginning of this series, we looked at a particular pest, the raspberry cane gall midge. Is that the common name? That there are some, significant interactions with disease with that particular midge. It's similar, and so and we see disease often in these fields. So that remains a question that we do have people on and we'll be looking at.
Maybe this is a question for Bruce. Have you noticed any midge infestations in organic production, or those farms that have maybe extended rotations?
No, I haven't noticed any.
Okay.
I haven't looked at anything in organic at all. It's all been conventional.
Okay, me too. I don't know why they wouldn't or couldn't infest. I mean, I would expect them to do very well in organic. Yeah, as compared to.
Well, this is strange. I do. My big garden is organic, basically, and I had KS42. I had a particular soybean in that just to increase seed. That was 2018 or so, and it got ravaged by soybean gall midge.
Okay, so, good.
So just and that's anecdotal. It didn't, but in my particular. And it was probably worse in my garden than it was in the fields that were around. It was a little bit in the fields around. I saw some on the edges and stuff, but it really hit the particular line that I had in my garden. And, that's organic because I'm lazy with respect to spraying. I just never spray anything, and I use chicken manure and stuff in it. So,
go ahead.
Huh?
I was going to say our problem is the adults can fly. We just don't know how far.
Yeah.
I was going to just add to Tom, I had an organic garden in my backyard in Lincoln, and it got infested with soybean gall midge. So that's 2 observations.
Yeah.
And pretty heavily infested.
We had Heath ask if we were looking for farmers to work with, and I would say absolutely yes. I'm not sure where you're from, Heath, but if you've had problems in the past couple of years, we would love to work. If nothing else, we'll do a little bit closer inspection, and we're always looking for additional data and spot checking kind of activity. So please get in touch with your state rep, or if you cover a region, get in touch with us. And then Jim asked, how soon will the presentation be available online? It takes a bit to do the closed captioning, but I'll have to ask Phyllis for sure, but I think it takes about a week or so. So today's presentation will be probably ready by the end of January. We had a question about, I guess, basically like I don't know if it was a trap crop or buffer strips of like rye, wheat, or grass. Do you think that would delay emergence or suppress midge population into currently growing soybean?
I don't know about a buffer strip, but one of the things that I'm kind of curious about is if we can trap crop them in the previous year's field or on the edge by planting some soybeans. The idea worked a lot better when we thought the infestations were tied to early planting more than it does now, but
And I think,
it's possible maybe.
and Justin, what was your way of encouraging midges? Didn't you have some buffer
Yeah,
small grains?
that's part of this conversation, I guess. So what we did was we planted oats into last year's soybean field as a way of possibly increasing adult survival and emergence, providing dense vegetation in those sites, and we did see pressure out from those sites. That's not something typical anybody's going to do.
No, I think the point is, if you have planting something that's dense vegetation, seems to be a place where it might harbor this midge before it goes right into the soybeans. So I wouldn't think that would be a way to limit it unless they were very broad, which kind of defeats the purpose.
Terry asked about using maybe multiple strategies and talked about specifically mowing grassways and using a residual insecticide. I'd be curious to know what Terry thought is a residual insecticide. That is an ongoing debate with myself and others. And has anybody looked at doing a kind of a combo approach? I don't think we haven't yet. Okay. That's definitely something we'd have to understand the strategies individually. And then as we get more sophisticated, using multiple strategies to see if there's a synergistic effect. But definitely the cultural control aspect in addition to insecticides is something that I think we're really interested in learning more about.
Yeah, I think that's an ultimate goal, is to have this multi-pronged approach.
Yeah.
And using the cultural and the more conventional insecticide approach to deal with this.
Yeah. Someone specifically asked about bifenthrin. I've looked at a couple different pyrethroids in alone and combination with neonicotinoids, but I have not used bifenthrin on its own. Have you guys? No. Okay.
Not on its own.
Just as part of Hero.
Yeah.
Okay.
Yeah.
Okay. And then Douglas asked about the weather conditions that you had for 2020, Justin, and maybe the drought impacts. I think that's the question he was asking, could have impacted maybe either adult emergence or some of those yield impacts that you showed.
Yeah, it's a good question. I saw it earlier, so it gave me some time to think about it. Getting down to 9 or 10 bushels is pretty dramatic, well beyond probably your typical drought scenario. Plus, we did document later infestations and presence of larvae. They were in very high number in those fields and locations. It's not on an irrigated site, so it would be under potential pressure, from that type of stuff. But it's a good question. I can just tell you as an entomologist, there was plenty of pressure out there to represent the potential loss, and maybe later drought could be an interaction with something like that. Possible.
Yeah, Angela asked, Justin, if you found midges in your backyard, what would be you don't exactly live in the middle of Lincoln, but how far would a midge have to fly to see commercial or like rural farming?
Yeah, this is a good question. I can't rule out the fact that I didn't bring it home. so no matter what we say, I can't eliminate that fact because I am in infested fields. It's always a concern. We did go through our neighborhood and found sweet clover in our neighborhood, which is a host for soybean gall midge. So we were only 600 yards separated from some sweet clover, and I'm right actually on the edge of town, so I'm only a mile or so from nearest soybean fields. But yeah, I like the thinking of the application.
Yeah. As opposed to Tom, you live in an acreage, don't you? You don't live in city limits.
Me?
Yeah.
Yeah, I live on an acreage, and
Okay.
my nearest neighbor is a mile away, and I'm surrounded by corn and soybeans, some pasture.
Sounds pretty nice.
So yeah.
Okay, thank you. And then we had another question from Boyd. Would there be any advantage to using thymate and corn, where soybean was last year?
I don't know. I would say stick with soybean for now. I mean, the idea is that we're impacting the larvae as they start to feed on plants that have uptaken the chemistry. I would stick with that. I've not done any tests. I don't know if anybody else has any comments.
Okay, we still have well over 100 people, which is fantastic. It shows a lot of interest on this emerging pest issue. I just want to make sure again that if you need the credits, you have the QR code, or you can sign up for the Google form. We're going to continue to post upcoming events, and as research gets out there on our soybeangallmidge.org website. Wondering if there's any last questions kind of coming in. That website would also have all of our contact info for your respective states and things like that. So any other comments, questions for the group that you thought of as we rolled through all those Q&As?
I would just say if people are facing issues with this and want to get involved with us, we can't guarantee we can be everywhere. We try to span out our networks each year, but do get a hold of us. We encourage that. And if we can't set up a research site, like Aaron said, we can make a pass by. We're expanding our network a little bit south here in East Central Nebraska. And so we'll have some cages, hopefully in Otoe County area, which we didn't have the previous year.
I guess I would add, there's a couple things here and there that look like, might have some promise, like the mowing thing. And so if you do something like that, because I know several people that probably will do some of that, it's always nice to have a check, as far as what kind of check or how much of a check, the best thing to do would be to call one of us, depending on what you might be doing. But there's a lot of farmers out there that are forward thinking, and they're trying some things. They hear what we've done, or they see what we've done, and we might not be able to have things on their property just because we get spread thin, but they do it. And so leaving checks is always what's needed to really tell if something's really going on, or if you just hit the jackpot that year and you didn't have midges so bad. So try to leave checks and to drop us a line or call us to see how you might do that the best way, so that you can get some good data on your farm. Because, your farm is the best place to do research to find out what's going to work on your farm. Microclimate, environment, all those kind of things, your farm operation, do you use manure, blah, 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 all those things might affect something. So if you do, it's good to do research on your farm. But if you do want to try things on your farm, it's always good to, it's necessary to have checks to really understand if you're having an effect or not. So be sure and give us a call or an email, and we can help you out there.
Yeah, that sounds good.
Yep. Definitely, if anybody is in Minnesota is interested in experimenting, I can help you set up some designs.
Yeah, and a lot of things we're doing, as we mentioned before, are kind of replicated small plot. And ideally, what we like to do is have a more applicable project where we're looking at whole farms. And so as we get a little bit more sophisticated in our research, we want to see what that means for farmers. So we start small, but hopefully we'll get bigger over time. Yeah, okay.
We got one on emergence cages. Actually, I think it was asked earlier too, Aaron.
Oh, sorry about that.
No, that's
Yes.
okay. I think it was, is there build plans? Can we build our own? And I think somebody earlier asked, how do we track adults? And that's a good one to go back and watch the session 2. But just briefly, we have cages through our network, and they require, they're not as what would I call it, reliable as what we would hope. And there's going to be effort made to improve that. We could certainly provide people with plans, but do be careful about misidentification if you're going to track one of those. A lot of things look similar as you catch in those cages. And so if you go ahead with that, don't be afraid to send us stuff as you find it, and we can help confirm that for you.
Yep. It's always nice to have a little magnifying glass or hand lens too when you're dealing with insects like this, if you're going to be looking at trying to look at adults.
Mm-hmm.
Yeah, thank you. I think I was trying to scroll through all these questions coming in, so I hopefully we've addressed a lot of it. Okay, so I think with that, we're in double overtime right now. So we just want to thank everyone for staying and asking a lot of great questions. It provides a lot of research inspiration for us, and we hope to continue this type of format, whether it's virtually or in person in the future. So thank you so much. if other things come to mind, soybeangallmidge.org has all of our contact info. So please keep in touch as we progress. And so I think with that, thank you all. Till next time.
Thanks.